Hey, good morning, everybody, or afternoon, depending on where you are. Hopefully, people can hear me. It looks like I'm live. We'll see if anybody rolls in. Okay, I wanted to get right into it. So, this video is going to be about discussing basic functions of the mind, neurocognitive or neuropsychological domains that are involved, and what each of these domains looks like in terms of function and dysfunction. The reason I'm going into this is because when we talk about neuropsychological domains or how the mind works in general, I see a lot of confusion. Oftentimes, people talk about the mind as if it's the totality of one's own psychological functioning. We know this is not the case because the mind is something that can be destroyed, it can be built up, and most importantly, it can change at any given time. And it does. Our brains are very neuroplastic. So, when we understand the mind, we're talking about a lot of different domains that involve the processing of information. The way information is processed not only varies from person to person, it also varies across species, and it also varies within persons, meaning that over the lifetime, certain cognitive domains can be built up, certain cognitive domains can break down, and they change continuously throughout one's own lifespan. Simple example of that, imagine your own cognitive abilities. Imagine what that might be like in your, can't tell if somebody came in or not. Imagine what your cognitive abilities might be like in your 80s or 90s. Certainly, different domains change and can break down. All right, I'm going to switch to my document here. Hang on one second. Okay, looks like that's visible. Should be a OneNote document. So, basic definition up here at the top. Mind refers to psychological phenomena or mental activities that involve the processing of information. Importantly, the mind is something that can be impacted by the dimensions of consciousness. I don't have consciousness included in here as a function of the mind. Hey, if anybody checked in, I'm not sure if you did or not, but you're welcome to ask any questions. Feel free to participate. I'll do my best to answer things for you. All right, so the mind here refers to, again, different ways of processing information. And again, if you have any questions, feel free to ask here at any point. The mind breaks down into different domains, right? So we're looking at attention, effort, executive functions, generalized intellectual functioning, learning, language, memory, and so on. I'll go through all of these hopefully by the end of this live stream here. I want to break down, though, before we even talk about any of these domains, why I have these different categories in terms of the mind. So we know that psychology, when you break it down in terms of etymology, it's the way that we study the soul or the mind. Pretty much in modern day science, we talk about the mind, right? Evidence for the soul is lacking. That's a whole other discussion I don't want to go into. So when we're talking about the mind, we're talking about the way we study psychology, more or less, because we know from brain behavior relationships that functions of the mind can change over time based on how the brain is working or not working. And this comes down to different areas of neuroanatomy, neurochemistry, pharmacology. All of those different things come together and impact how the mind works. So we know from a field that we call neuropsychology, which is the study of brain behavior relationships, that the mind can change in terms of functioning based on a lot of different domains that I just mentioned. Hey, for whoever just came in, feel free to ask any questions. Happy to answer as needed. Neurosurgery is a good example of what dysfunction in the mind can look like, right? The neurosurgeons often get firsthand experience and see that the mind is something that you can directly alter from electrophysiological stimulation, for example. That refers to taking an electrode, activating different parts of the brain. For myself, experientially, I worked in a variety of neurosurgery and epilepsy settings. One of the most interesting things we got to do was looking at epilepsy patients in terms of a grid essentially that was placed onto the patient's brain by a neurosurgeon. And they would place this grid in a certain area where they suspected epileptic activity to be taking place. And there were different combinations of electrodes on the grid that you could activate or deactivate. There's a different set of machines you can use for that. And we would go through each of the combinations on that, I believe it was a subdural grid, and look at what happens when we apply a little bit of electricity to different parts of the brain and different combinations on that grid. And as you can imagine, different functions of the mind would be impacted based on the areas that we sent an electric signal to. We were looking for different spots that, all right, when we apply an electric current here, we see that the person might have a seizure, there might be a change in certain psychological functions. Is it acceptable or not acceptable for the neurosurgeon to take out that portion of brain or risk damaging that part? As an example, if the subdural grid was placed over an area that involved language functions, we probably would not want to mess with that area, right? We really have to weigh out to what extent are the seizures causing problems for the person versus to what extent are these specific language functions needed. So pros and cons there in terms of what functions of the mind are most important in terms of how somebody wants to live out their life and carry out different functions in terms of what they want to do or not do. In short, the point I'm trying to make here is that you can see directly from brain behavior relationships, meaning brain activity here seems to be correlated to certain behaviors here. We can see that there's different domains and they have very specific neuroanatomical areas. I won't be going into neuroanatomy much for this live stream. Here, I just wanted to give very basic coverage for different psychological domains. All right, so in terms of attention, this is the first domain that I have here, and by no means are these rank ordered in any way. It's just the list that I happen to have. I also want to add that the domains here that I'm talking about, they are not comprehensive. There are so many different psychological domains involved, but these are the ones that you tend to boil down to when you look at core mechanisms of action. So somebody might say, something like attachment theory and the way infants or newborns or young children, the way they attach, that might be a function of the mind. It's like, yes, but what core mechanistic psychological functions does that boil down to? That's more or less what we're looking at here. And again, this is supposed to be a very basic overview to help guide what I'm talking about when I mention the mind in future videos and in past videos as well. Okay, attention is the first domain. This is a very interesting domain, and actually in my book, which will be coming out in several months, this is the most important domain that we need to train for experiences of awakening. Again, that's well beyond the scope of what we'll talk about here. The challenge is defining attention, right? As people like to say, everybody knows what attention is, but nobody knows how to define it. There's actually a very well-known article in the field that I want to show. I'm going to pull it up here. All right, I'm going to try to share this, see if this works. Okay, there we go. Yeah, it is called No One Knows What Attention Is. And I always laugh a little bit when I see this article pop up, because it does pop up from time to time. We don't need to go through this entire article. It's it's well beyond the scope of what we need to get into. But the main takeaway here is that attention is not a unitary construct, as we like to think, right? Attention seems to be, we're still actively researching this, trying to figure it out, but attention seems to be the way that a variety of neural systems that involve cognitive, behavioral, and neuroanatomical substrates come together. And attention seems to be some property that involves the workings of multiple systems. It's not some unitary construct like, uh, maybe not the best example, but kind of like a language function, right? We roughly know based on neuroanatomy, if we lesion this specific part of the brain, it is going to cause this specific type of deficit. Maybe I'll show that later. There's a set of tracts we call the arcuate fasciculus. It goes back between Broca's area, Wernicke's area, and there's a whole map of different types of aphasias that you can see. But anyways, attention is, I think we could pretty reliably say, the most complicated function of the mind that we're going to see in this list, because not only do we not have a clear definition of what attention is, I mean, yes, we have some general ideas, but we don't have a comprehensive mechanistic explanation for attention. So not only do we not know exactly what attention is, we don't know exactly how it works. We know it's some kind of interface that involves our perception and consciousness, but how the relationship pans out there, it's really not clear. I'm going to switch back to my OneNote here. Okay, now when we look at different domains of attention, we're talking about things at a basic level here, but this is generally what we see within the neuropsychological literatures for how attention works in terms of the different functions of attention. Focused attention is the first area. This is just like it sounds. To what extent, hey, to whoever checked in, feel free to ask any questions. I'm going through different functions of the mind, or just hang in there and listen. It's up to you. Okay, we lost him. Focused attention refers to the different degrees of attention that are applied to a given stimulus, right? Think of it like a magnifying glass. When you take a magnifying glass, to what extent are you focusing in versus just getting a broader view, or perhaps not even applying your attention at all? So focused attention readily changes at any given time. Selective attention, this overlaps a lot with executive attention, but essentially it's being able to select a certain thing for attention while ignoring non-relevant information. So if I put my thumb up here, for example, are you able to pay attention to my thumb, or do other things in my environment, like the bookshelf or my face or whatever, do those distract you and pull you away from what you're trying to select your attention onto? Executive attention, this is response selection and control. So it's, if we had selective attention, for example, executive attention is kind of like the circuitry behind that's determining what you're attending to or not attending to, and how essentially executive functions, which we'll talk about later, are being applied to your focused attention, or I'm sorry, to your selective attention. All of these domains of attention are interconnected. However, selective and executive tend to play a special role together. Okay, and then divided attention, it's also just like it sounds. There's a lot of nuances to discuss here. I won't go into it. To what extent can we manage multiple tasks at the same time? Okay. One example that I should show. So what do disorders of attention look like? I'm pulling up an image as I talk here. One of the most common examples, especially in today's age, that we see for attention is ADHD, right? I mean, ADHD is pretty overdiagnosed. However, there are general not general, there are specific true instances of ADHD as well. But anyways, ADHD is typically thought of as a neurodevelopmentally based dysfunction of attention related domains. When attention is disrupted, you can see in this case with ADHD that medications can help with restoring attention. There are also behavioral and therapeutic strategies that can help out as well. But typically we turn to medication first. So let me get this image here. I'm going to see if I can drag it over. Yeah, perfect. That worked. Okay, so this is something that you get to see whenever you're doing neuropsychological testing. It's relatively common clock drawing task. Here the hands are set to different, but typically we might say something like 10 past 11, set the hands, draw the numbers, draw the clock. And one of the things we're looking for, aside from executive functioning abilities, are your attention capabilities, because we will see that when attention is disrupted, there might be a hemi-neglect syndrome. We know that each of the eyes has two visual fields. So the left eye can have a left visual field and a right visual field, and the right eye has a left visual field and a right visual field. And on top of that, the right hemisphere is primarily the one that dictates the degree of attention that's applied in such a way that as more attention is needed, more right hemispheric functions are recruited, and vice versa for narrowed, focused attention and left hemispheric functions. So what we see in this case is that there's obviously neglect. Now, the person was able to draw a circle. There's a variety of reasons for that. You could even say memory might be involved, just knowing this motion, of being able to draw a circle. But when they place all the numbers, everything's on the right side, right? So we might say that there's a hemispatial neglect syndrome here. Hemi meaning half, spatial within your visual spatial field, and neglect meaning missing. So half the field's missing there. Okay, I'm just going to leave that for attention, because otherwise we might not have we might not have time for other domains. Speaking of attention. Okay, effort. This is another one that, yeah, it's more common in neuropsychological domains, but you do see it across fields, especially for certain clients you might see with disability type evals, workers comp evals, clinical cases, people who might have what we call secondary gain, meaning they're showing up to an appointment explaining that they have issues with one thing, but really they're looking for something else, kind of like someone who might go to an ER claiming that they're having leg pain, but really what they're trying to get are maybe morphine type medications or painkillers. But generally, effort refers to the degree of physical and mental resources willingly applied for completing a task or assessment. This is just like it sounds. When we have effort, we are talking about how well somebody is actually applying their functions of the mind into what they're doing. And hey, to whoever came in, feel free to ask any questions. Oh, they ran away. All right, so effort, yeah, that, you could have all of your functions of the mind working just fine, but if you don't choose to consciously and voluntarily apply them to the full extent, then you are going to see lower performances, especially on neuropsychological batteries. We have ways to control for these things and ways to detect low effort. People often use the term malingering for conscious low effort, typically for secondary gain, but that's actually very hard to prove. It typically comes out as the word feigning. Feigning can be for a number of reasons. Malingering has a very specific outcome intention. So yeah, effort, I think that one's relatively straightforward. We won't spend too much time here. Now, in terms of what we're talking about in this channel, effort is really important as well, because effort can also be subconscious or unconscious. It doesn't have to just be conscious. When we're saying subconscious, we're referring to functions of the mind that are not readily available to one's conscious awareness. However, they can come into awareness based on the types of practices that are done. Similarly, something that's unconscious, we can't bring that into conscious awareness no matter what we do. Vast majority of our functions are unconscious. However, even what you do consciously or subconsciously can impact your unconscious. Okay, let's move on. Executive functions. This involves a higher order set of cognitive processes that exercise control over other cognitive domains for attaining goal-directed behavior. That's just a really fancy way of saying it's the way that we get things done. In therapy or neuropsychological domains, we often describe executive functions as very similar to how a business executive acts, right? They're very organized, they plan things out, they're looking ahead of time, they're flexible in terms of thinking patterns, at least that's what you would hope for them to be. So there's a whole variety of different functions involved with executive functions. We won't go into all of them, but some of them, which I've already mentioned, include planning. So planning is just like it sounds, it's a face valid term. Cognitive flexibility, to what extent can you switch between concepts going back and forth? If I had you count out numbers from 1 to 26 and then alternate letters of the alphabet as well, 1A, 2B, 3C, 4D, and so on, that would involve a degree of cognitive flexibility and also set shifting as a function as well. Inhibition is being able to control your impulses. So when we're talking about inhibition, whenever you're doing something, can you keep yourself from engaging in other functions as well? Working memory, that's your, we'll go into that in memory. I'll come back to that one. And I think I got all of them here. Organization as well. So yeah, lots of different functions there for executive abilities. Someone who has dysfunction in terms of executive functions, that's common in ADHD as well, right? We can see that they're disorganized, they can't plan things out, they're forgetful, they have difficulties with putting things into a sequence of continual events. A lot of different disorders involve executive functions. These are very, very heavily dominated by frontal lobe functions. There are a variety of neural networks involved as well, or brain networks that dictate executive functions. However, they seem to be very well pronounced, especially within our species, because they have such important utility for completing goal-directed behavior. If you don't have your executive functions, you are not going to get things done in a meaningful fashion. Just ask anybody with ADHD, countless patients, tell me that, all right, I start a task and then I'm good the first 20 seconds, and then I come back 2 hours later and I've done everything except for the task at hand. Okay, generalized intellectual functioning, basically IQ. Okay, this is what we think about when we're talking about intelligence. Now, a few things to say about IQ. I would say within the public domain, IQ is conflated a lot. IQ is just a small degree of one's overall generalized intellectual functioning. But within psychological theory, psychometric theory, we need something to capture at least some generalized intellectual abilities. I'm trying to say that there's much more at play than IQ when measuring someone's intelligence, but IQ is the general gold standard that we do use. In terms of what IQ correlates to, someone who has a very high IQ doesn't necessarily correlate to intelligence in all different areas, right? We know IQ is good at measuring certain specific things. It's not good at measuring everything in terms of intelligence functions. So generalized intellectual functioning, I think we know pretty well what that means. Impacted by, just like every other function of the mind, it's impacted by a variety of genetic, environmental, and experiential factors. Genetic factors, we see a very high correlation in terms of IQ across families, within families. Environmental factors, if you imagine someone who has a traumatic brain injury, for example, they could lose certain functions of the mind that can impact their IQ. So it's very dynamic, just like other functions of the mind. We'll go on to learning next here. So learning is also, it's face valid in terms of how you can understand it. It's a multifaceted process involving the acquisition, retention, and application of knowledge and skills. Essentially, to what extent can you learn things, retain things, and retrieve information? Those are the three main things we're looking at for learning capabilities. And learning typically comes in the form of verbal and nonverbal information. All right, we won't spend too much time on learning because it's so closely involved with other domains of the mind. Now, language is a big one. This is perhaps the second most complicated after attention because language is just the foundational basis for pretty much everything we do, especially in Western societies. And whoever's in, feel free to ask any questions. Happy to answer them as I can. So, language involves, we typically think of language as words or phrases, but it goes more fundamental than that. It's our ability to take information and put them into symbols that we can manipulate for goal directed behavior. A great example of this, instead of just the English language, is mathematics, right? Mathematics is essentially the study of taking information and putting that information into a symbolized lexicon or language that we can parse into symbols and then use. So if we're looking at the heat distribution of an engine, for example, how can we take those thermal signatures and put them into mathematical symbols so that we can manipulate and change variables about that engine? That's what we're doing with language. It's a very, very crucial function. It's probably the most important function other than executive abilities that makes us human, right? It also comes at a cost, as we talk about in acceptance and commitment therapy and also the psychology of awakening. It's really important to see how language is double-edged. Yes, it's really good at putting things into symbols so that we can manipulate them and meet goal-directed behavior, but it also comes at the cost of simplifying reality, right? To take something and put it into a symbol, we are losing certain parts of information. An engine, for example, using the same thing that I was using before, the engine continues to work and there's so many different variables at play, but if you only look at heat signatures, that's a very narrow focused view of attention, but it is very detailed and gives you a lot of good information there. So language functions, I am going to pull this up. So hang on one second. Let me see if I can find this. I'm not sure if I'll be able to get a good image of this, but I will try. I am looking for the different types of aphasias that are involved with language functions. So when I'm talking about aphasia, that's the set of disorders that impact someone's ability to communicate information in a meaningful fashion. So hang on one second. I'm going to find this. Oh, perfect. Here it is. Okay. So language functions. This is a great chart here, and we won't go into the specific nuances of this chart, but I just want to point out on a very basic level, for the vast majority of people, especially right-handers, which is pretty much everybody, and most left-handers as well, your language functions are going to be in your left hemisphere, okay? When they're in your left hemisphere, we're looking at this red and blue region that I'm circling here with my mouse. Now, the red region, this is more so Broca's area. And then on the blue region, this is more so Wernicke's area. Very, very simple way to understand these. Broca's area is like the motor control for language functions and being able to communicate expressively. And then Wernicke's area is more so the ability to understand information and comprehend information. So someone with Broca's aphasia, for example, you might hear them stutter or perseverate a lot. They might keep saying repetitive terms, like there's a famous video on the internet, a guy keeps saying tono, 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 but he's trying to explain things very well. That sort of, a little more nuanced than that, but that sort of gets at the Broca's aphasia piece. And then the Wernicke's aphasia piece, they have difficulties comprehending language. So you can break down the flow chart here in terms of whether someone's fluent, whether they comprehend, whether they can repeat. And we see that there are various different types of aphasia. Lots of different neuropsychological tests we can use here to measure these types of aphasias. But, it really varies from person to person, and it also varies in terms of specific injuries. So I'll go ahead and just leave it at that. There was a little bit more I was going to say, but I'm just going to leave it out just for the sake of time to make sure we're good. Let me see how many more we have. Yeah, we got a lot more. Okay, memory. This is also a pretty well-known function of the mind. Memory is the capability, so it's essentially what we're using learning for, right? Learning involves memory. Learning involves encoding, storage, and retrieval, as I mentioned earlier, and then memory is the extent to which that is functionable for a person. So memory can be split up into sensory memory, short-term memory, long-term memory. And short-term memory is temporary storage of information. Long-term, you can split that into explicit and implicit types of memory. Explicit would be something you can consciously recall, and implicit is not really consciously recalled, but it is memorized nonetheless, like a procedural type memory. So this is someone who learns to ride a bike, for example. They ride the bike once, and then once they get it down, they are good to go. They don't really need to learn it again. Now, semantic memory, that's pertaining to factual knowledge, and then implicit, as I've already mentioned, that can be procedural, it can be primed, or it can be conditioned. Memory is really important in the sense that it determines to a good extent how we utilize our other functions of the mind. There's a lot of good case examples out there for different types of memory dysfunction. You can see very complicated sets of problems that arise from memory issues, which might include things like aphasias. It might include things like, typically aphasias. I'm kind of blanking right now in terms of the other ones. I was thinking about something else. There's a couple case examples I wanted to show. HM is one of them. I think Clive Waring is another one where he kind of forgets information every few seconds. So he meets his wife, and then like 20 seconds later, he basically thinks he hasn't seen his wife in years, and then he meets her again, and it's kind of like meeting for the first time, but every 20 seconds. There's a video out there, I won't pull it up, but it's very, very interesting. And then HM was a case study where both of the hippocampi in each hemisphere, those were purposefully lesioned to help deal with certain types of seizures, and that caused a variety of memory problems for that case study as well. I don't remember if I said aphasia earlier, but I meant to say amnesias instead. There are a variety of amnesias. You can see, you can even classify to some extent the type of traumatic brain injury someone has had based on the degree of retrograde or anterograde amnesia that they might have. Retrograde meaning before the event, anterograde meaning after the event. So memory also spans verbal and nonverbal domains. Pretty self-explanatory there. Okay. So yeah, this one is pretty interesting. Again, this is kind of like attention. We all kind of know what emotions are, but we still don't have an agreed upon definition in the field, believe it or not. And this perhaps may be because there is not a singular definition for emotions. But generally, we understand them as subjective experiences that are involved with a variety of physical, mental, behavioral states, which may or may not be associated with goal-oriented action. I know that's a super, super broad definition, but that's the best we can do so far when we talk about emotions. It's just so difficult to parse them out into a clean, coherent definition. So emotions are primarily associated with the limbic cortex of the brain. This is kind of like a ring at the bottom. I'll get a picture for you. Okay, let's see. Yeah, there we go. So the purple area, more or less, the cingulate cortex and this ring that goes around the bottom here and through the cingulate cortex as well, that's where we see a lot of limbic related functions that involve emotion. And interestingly, the brain is wired in such a way that emotions, learning, and memory are very, very closely related to each other. We can even trace out, to a good extent, many of these different neuroanatomical areas based on neuropsychological functions. So the main two components here I wanted to talk about, the amygdala and the hippocampus. We're going into basic psychology here. Let me scroll up so you can see that better. There we go. The amygdala, this is, I think it's Greek for almond, and it's essentially an emotion processing center. And the hippocampus here is essentially associated with the creation of certain types of memory. As you can see, they are directly attached to each other. And this makes a lot of sense when we just take a second to reflect on our own memories, right? Memories have a lot of emotional content to them. And you could even see how, from a survivability aspect, how it's important to associate emotions to memories. If we go somewhere and we have a experience that almost leads to a grave injury or dying, it's going to be involved with some pretty strong emotions, right? Just ask any trauma patient. They will have certain associations to near-death experiences that are perhaps maladaptive for them because of how strong those emotional associations are. I've talked about a case example before where a female I was seeing, she was sexually assaulted and she remembered looking at the clock as it was happening. And after that encounter, even months and months later, just looking at a clock was very, very traumatic for her. So emotions are very closely involved, not only with memory functions, but also with many other mind functions as well. Yeah, I can go into this briefly. So just very briefly here, we have a very specific set of neuropsychological functions here. So the amygdala, as we said, emotions, here we have memories, and then there's a very specialized tract here that goes up through the fornix here, and then we have a fasciculus or white matter tract that goes up into the thalamus, and then the thalamus is kind of like the gateway center for the brain. It will take that memory, that emotional content, everything that was encoded, and it will disperse that throughout the brain in a variety of ways. We know that the hippocampus is involved with the creation of certain types of memories. However, for memories that have already been created, they seem to be stored throughout cortex. Still being parsed out in literature here. But you can see in certain disorders like Alzheimer's disease, for example, where there's degeneration of much of the cortex, especially in fronto and parietal and temporal areas, over time, that memory seems to be heavily impacted. And there's much more neuroanatomy to discuss there. But okay, let's go on to motor functions. So we probably know these functions pretty well because they, again, are relatively easy to understand. Psychological and physical processes involved with voluntary and involuntary movements. Fine motor skills, that's something we might use a grouped pegboard for. Gross motor skills, walking, being able to sit still, moving my hands right now, all of those are different motor functions. Now, another thing that is important with motor functions is that I wouldn't call them separate, but there are different processes for psychological and physical areas for motor functions. For example, we know that if we lesion certain parts of the nervous system, that part of your body isn't going to work, right? If we take a stroke, for example, and it gets you in the right spot for There's a whole tract of functions for motor and somatosensory areas, but if they get you in the right spot with that stroke, then you are not going to be able to move certain parts of your body, or it might be more difficult to move certain parts of your body. So we can assess that pretty well. That's a type of motor function. Psychologically, you can see impacts as well. Somebody might not have a stroke or a lesion, but if they have severe depression, then their psychological, we call it psychomotor movements, those are slowed. We can't really see anything wrong physically with the person, but when we look at the psychological aspects, someone with severe depression, they move a little bit slower. Other functions of the mind might be impacted as well in what we call a pseudo dementia presentation. I won't go into that here. But yes, the motor function is very, very important and something that we can behaviorally train and control as well. Okay, personality functions. So this is a very, very complicated area. Personality refers to unique and stable pattern of thoughts, feelings, and behaviors that consistently influence an individual's interactions and experiences. Or, as I like to say in simple terms, it's the way with which somebody engages with their environment. It's a very, very basic term. Another way to think about it is if you were asked to describe somebody in terms of their characteristics, the things you say, that's most likely a description of their personality. Somebody's personality that can involve different traits. So when we're looking at the ocean model here, ocean refers to these 5 traits here. I think I can highlight them. Yeah, there we go. Extroversion, agreeableness, conscientiousness, neuroticism, openness to experience. These are really important because they are, as far as we can tell in our current literature, they are very, very well biologically based functions of personality. So we will see variances in extroversion, the degree with which somebody engages with their environment in terms of looking outward or looking inward within oneself. Agreeableness, this is the extent with which somebody would want to essentially stir up the waters to meet certain goals or express certain thoughts. Conscientiousness, how hard or how well you work towards completing goal-directed behaviors. And I'm giving really basic definitions here. I don't want to go in high level of detail. Neuroticism, this is a trait that is very closely related to a variety of mental health disorders in such a way that the higher you are in trait neuroticism, the higher your disposition to develop mental disorders of any variety for, for complications related to like psychosocial stress, difficult life events, injuries, things like that. So your resilience, that's closely related to this as well, that might be lower. Openness to experience, this one means to what extent are you novelty seeking for your environment. So someone who's really high in openness, they are constantly seeking out novelty in the environment. They're constantly looking out, doing new things, engaging with new things. Seems to be some correlation to, I believe it's ADHD when you're really, really, really high in openness. You can kind of see that as the extreme end of openness to experience. And then on the other hand, you might have somebody who's very closed off to experience, right? What they know is what they know, and they do not seek out changes or disruptions in their environment. Personality styles are all based on evolutionary functions, right? As you can imagine, there's many different ways to navigate an environment. There's many different ways to function within reality. Personality describes the variety of behavioral traits that people have that seem to work in their own ways for navigating the environment. Okay, personality, as I mentioned earlier, it is also shaped by genetic and environmental factors and has a very close relationship with how mental health is managed and to what extent people can tolerate psychological distress. Okay, looks like we got 3 more, so I think we're about good on time here. Okay, processing speed. When we think of a computer, and the RAM chips that we put into the computer and how well those functions can be carried out at any given time. That's processing speed. Similar thing to people, how well can you analyze, process, carry out, respond to information? If I was really slow in processing speed, I might talk like that, right? I might take a long time to think through things. Now, there might be other reasons somebody pauses or slows down their speech. They might be thinking more carefully about what they're saying. But when we see people who have had neurological insults or types of brain injuries or neurodegeneration, processing speed is also commonly impacted. A common example for processing speed issues that people might know at least on some level is multiple sclerosis. We know that the way neurons function, the myelin sheets that help the electrical conduction, the electrical signals conduct, if those are impacted, then that can cause a variety of problems in terms of processing speed. So another thing with processing speed that's important to understand is that when processing speed is impacted, all of your other functions are impacted as well. For example, if your executive functions are good, but you have issues with processing speed, the extent to which you can carry out executive functions is going to be limited because it takes you much more time to process information. Okay, I want to spend a little bit of time on sensation and perception. This one's really important. I know I'm saying that they're all important because they are, but sensation and perception, these are especially important for psychology of awakening because conventional reality is more or less entirely comprised of not only workings of the mind, but primarily sensation and perception. When we try to understand sensation and perception, it's good to reflect on our own experiences because, let me grab a picture here, because our own experiences show that the extent that we can engage and understand reality is limited by our own psychological functions. I know this is really hard to understand for people who've never come across such an idea before, so I'm going to pull up a little chart here. Okay, hopefully people have seen this before, at least in like a high school or college class. This is the electromagnetic spectrum. Okay, electromagnetic spectrum. This is, what's an easy way to define the electromagnetic spectrum? It's the range with which light is organized in terms of, it's not on here, but frequency, wavelength, energy. It's basically the spectrum with which, I'm trying to think of a better way to define that for you all. Frequency and wavelength, we'll just say both of those together. The point I want to make here about the visual spectrum on the electromagnetic spectrum is that it's a very, very small sliver of what we can see, right? Let me rephrase that a little bit. So the electromagnetic spectrum, it ranges from radio waves all the way to gamma rays, and you can see that the wavelengths here and the frequencies, those get altered as we go down the spectrum. And the wavelengths are species specific in terms of what can be perceived or not perceived. So a bee, for example, might see things more so in the ultraviolet, and then here we are in the visual spectrum. Okay, so we can only see this very small range of things, even though in reality, all of these different areas of the electromagnetic spectrum are available within reality for information processing. We can only process a small portion of the electromagnetic spectrum here. Now, this is important because there's a lot of information out there that we just can't perceive. We can use instruments to help ourselves get there, but nevertheless, there's always going to be some degree of information that we just can't perceive or take into our contents of experience. This applies to all the other senses as well. Sensation refers to the process of taking in information through the senses, and perception refers to the processing of sensory data. Okay, so senses, that's what I was just talking about in terms of being limited to what we can see. Our rods and cones within the eyes, excuse me, our rods and cones within both of our eyes are only able to see things within this visual spectrum. Seeing is not quite the right word, but it can only encode this data for our brain to process and then see. Perception is the way that that sensory information is processed, especially throughout the brain. These two work together in creating our subjective experience of reality. An example I can give you is let's say we took, I'm looking for a good image here. Okay, let's say we took this picture here. All right, most people are going to see what's on the left. There's a picture of a giraffe, it's in color. Now, you can have certain types of brain injuries that cause you to see reality in this way, right? The information to perceive in this type of color is still there, but our limited neural resources are now able to only see things in black and white because our brain has been injured in a certain way. We see this with certain types of color blindness as well. The small, medium, and large, or yeah, small, medium, and large cones can be impacted, and that can cause problems with being able to perceive color as well. Okay, and I just double checked that. Short, medium, and long, that's the correct three types of cones there. Some of the stuff is kind of rusty. I'm primarily within clinical and forensics, but it's good to know these things for all studies of psychology. Okay, visual spatial functions. So let me just finish up here with sensation and perception. This is important because it shapes the way that reality appears to us. Not the way reality actually is, but the way reality appears to us. Okay, visual spatial functions essentially our way of managing nonverbal information. That's probably the easiest way to think about this, being able to manipulate visual and spatial information. So when we think about solving a puzzle, for example, being able to put those pieces into a meaningful fashion, looking at the visual data that's involved, that involves a variety of visual spatial functions. Excuse me. The visual spatial functions that are involved with driving, for example, those are important because we find that people who have had certain types of brain injuries, they can no longer drive safely, right? They go down the road and then they might hit a mailbox, they might hit curbs. I remember driving with a business executive one time. She was from a company that we were looking at, and she had a pretty bad traumatic brain injury. I think it was a year or two ago. And she just claimed that she was fine, she could drive well, but you could tell just from the way she was driving that something was wrong. She was just very close to the curb on one edge, and there probably were other functions of the mind impacted as well. But she ran over curbs at least 4 or 5 times as we were driving down. It's pretty hard to not say something, but she kept claiming, and it was obvious it was really important to her, so we just didn't say anything. But yeah, visual spatial functions really, really useful and important for how we navigate our environment. If you don't have proper visual spatial functions, then you're going to be hitting walls, you're going to be having difficulties with parsing out information that's nonverbal. Those kinds of things get affected or altered. Okay, I've gone through all of the domains here. We've got a few minutes left, so let me look over again, see if there's anything else I want to talk about. Yeah, I'll come back to visual spatial functions. We can just finish on that. That's fine. The visual spatial functions, you tend to see these manipulated in a lot of meditative experiences. Meditative experiences involve training a lot of different visual spatial functions because when you apply more attention within meditative practices, you are shifting towards viewing nonverbal information. You'll notice that whenever you try to meditate, the thoughts that you have, they become distracting because they narrow your attention and they pull your attention. But when you are able to meditate a little bit deeper, visual spatial functions become altered a little bit in the sense that nonverbal imagery becomes more powerful and more salient. When we learn to utilize these visual spatial functions a little bit more, we notice that attention, and I mentioned right hemispheric functions earlier as well. Well, visual spatial functions are also heavily managed by the right hemisphere too. So all of these functions come together and recruit different ways of perceiving reality. Many people, when they look out and you ask them what they see or what they're thinking or what they're feeling, they often turn to their thoughts. They try to describe things in words and language and symbols. But it's just as valid to describe things in terms of visual spatial functions, in terms of nonverbal functions. You can see a whole set of reality right in front of you, and it doesn't need to be simplified, parsed down into language-based functions. You can just look and appreciate nonverbal information without assigning any type of label to it. Now, when you are looking at nonverbal information, you have to also understand that visual spatial functions are being painted, it's probably the right word to use there, are being painted by sensation and perception. What we can nonverbally see, perceive, or think about are constrained by the limitations of our own mind and our own neural processing. If I just tell you to see in ultraviolet or I tell you to see gamma rays, you will not be able to do that no matter how hard you try, right? Now, you can create instruments that transduce electromagnetic signals into ways that you can process within our limited neural constraints. That's a different story. That's using a separate instrument to translate information. You are still translating that information to a certain extent, and it's you could argue it's not the purest way to perceive something because that information is being transduced, but more or less that's the only way that we can do it. Even for ourselves, our own eyes are transducing information across light signals, electrical signals, chemical signals. All of those have to be used to convert information from reality through our neural processing systems and then putting that into types of information that our brain can process and then feed back to us and allow us to perceive. This makes it really difficult to, not just for nonverbal functions, but verbal as well, with the mind as a whole. It makes it really difficult to see where the limitations of our mind fall because we don't have anything to use other than our own mind. This is one of the greatest challenges within the psychology of awakening because you have to learn to use your mind to see the limitations of your own mind, so to speak. It's quite a difficult thing to do, especially experientially. I mean, it's easy to look at a book and know these things as facts, but to vividly live and experience them firsthand, it's very difficult to do, but it can be done with a lot of training and a lot of insight, which is a function I didn't even get into, but is also very important. Talk about that at a different time. Overall, the conclusion here, mind has a lot of different domains. I hope these basic definitions help to better understand what we're talking about when we discuss the mind. Feel free to refer back to this, or if you want to use any other diagrams, there's a lot out there that give basic definitions. It helps lay out the territory so that we know what psychological functions to work with when we're trying to understand different aspects of awakening. So I'll go ahead and leave that there. I know there's a lot of people that jumped in and out. I didn't see any questions though, so I'll just leave it open. If there's any questions in the comments, I will do my best to answer those. Thanks for your time for those of you who are here and for those of you who will be listening to this later on.